all calculator. Make sure you can graph those on the calculator pretty much. Vertical and horizontal shifts. I'm not really concerned about 5.1 because it's all calculator, but this one yields, and I'm just doing this as a review, x is equal b to the y. Now the only thing I'm used to is y is equal to log base a of x equal a to the y. So if you hear me say a to the y, that's what I'm used to. I'm not used to the b. But that is the definition of a logarithm. And this is very, 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 very important. If you was not here, whatever day we met last, then you need to write that down because that is the most important. Next to the properties, this is the most important rule that you can remember. Okay? And basically, you can go from a logarithm to an exponent or from an exponent to a logarithm because a logarithm is nothing but a glorified what? A glorified exponent. Okay? Now, you will hear math teachers go into the derivation of why a logarithm is a logarithm, but for your purposes, it's a glorified exponent. Think of it as an exponent with his pinky up in the air, okay? Because that's basically what it is. All right. Now we're going on, go back to I want to go back to that because we were in that's what I told you the other day. There's two logarithms that your calculator can do. One is LOG, and you'll hear teachers call it LOG. That's what they call it. And there's, usually a teacher will probably pick one before the other. And I do LOG, but it doesn't really matter. I don't sit there and go, oh, well, I really don't want to use natural log. I don't do that. I just, it's kind of like when you playing baseball, you just wait for the pitch, whatever pitch comes, you swing at it. It doesn't matter to me. But some teachers are like, okay, well, let's change this natural log into a logarithm. I don't do that. But LOG, pronounced LOG, is equal to log base what? Log base 10. Take your highlighter and highlight that because if there's nothing there, it's assumed to be what? 10. If there is nothing there, it is assumed to be 10. So I need you to write that down somewhere in your notes because you're going to see, a lot of times, you're going to see LOG of a number. And if there's nothing there, that's assumed to be log base 10, which means you can do it in your calculator. The other is natural log. And natural log is equal to log base what? E. Now those are the only two, these are the only two that can be calculated in your calculator. And of course, if you have your calculator, look at it. There's only two keys pertaining to natural log. Pertaining to logarithms. LOG and natural log. They're on top of each other. I don't know where it is, but y'all can find it. Okay? Question on that one. Does the definition of a logarithm apply here also? Yes. Okay? It's the same thing. So it's not a big deal. After we get through rewriting and equations, you're going to know LOG and natural log like the back of your hand, so it doesn't really matter. Make sure you can graph natural logs. That's a couple of questions on the test, And the same applies. The same applies if I give you this, and I'm just going to go over this for you because the parent graphs. Remember your first parent graphs, the first 8 paragraphs? Well, if I give you the natural log of x plus 1 minus 6, what is that? I've got a horizontal shift of 1 to the what? Left. And a vertical shift of what?
Down.
6 what?
Down.
Down. Okay, thank y'all for interacting, one person. Thank you. That means 1 to the left, and that means what? 6 down. Just like we did with completing the square, your vertex. I will just write it like this. F of x is equal to, and then down here, f of x is equal to a times x plus h, quantity squared, plus k. It's following that same pattern, okay? Now, what if I had a 1/2 out here? What would that do? All I heard was black. I don't know if the microphone cut you off or what. All I heard was black. Did y'all hear black? Okay. Enunciate and volume so the microphone can pick you up. What does the 1/2 do? What does the 1/2 do here? Make it skinnier or wider?
Wider.
Okay, so what does the 1/2 do in front of the logarithm?
Wider.
God, y'all, I tell you what. I don't know what I'm going to do with y'all. What about the, let me just color it red for some of y'all, it was a ball of fire. What about putting a 2 here?
Skinnier.
Makes it skinnier, more narrow. It compresses along the x-axis, stretches along the y-axis. What if I put a -2 there? Flips it. So I'm trying to, since y'all are so interactive with me, and since I know what you know because y'all are so interactive, I have to go over this stuff over and over and over because since we're so interactive with each other, I have no idea what you know because y'all are sitting there like a tit on a bull. Okay, so I don't know what you know and what you don't know. So the quadratic equation or the completing the square, the parent graphs, everything falls the same what? The same order. Just like when you go into trig, f of x is equal to 2 sine of x minus 3 plus 7. Okay? Same thing. Whether you do a exponential, all of them follow the same parent graph rules. You got a vertical shift of 7 up, you got a horizontal shift of 3 to the right, and it's compressed along the x-axis to make it what? I heard group. To make it what? When you compress along the x-axis, what does that do?
Makes it skinnier.
Thanks, I heard makes it narrow. That's what I heard. So that's not your fault. I think that was more of the microphone's fault. Y'all settle down. I think they really hate me. I really do. I think they hate me. I'm going to lose sleep tonight. Okay, there's the rules in case you were not here the other day. These are the basic properties that we ended class with whenever y'all were here last, whatever day it was. Okay, so log base b, and I wanted to highlight this. When the base and the number are the same, basically your answer is what? Don't say 1 because that's not true. What is the answer?
Same. It's the same.
The thing. Okay, that's good. The thing. What's it going to be?
Same. It's the same. What B is?
What's the answer if B and the base and the number are the same? What's the answer? Starts with an E, X, P, O, N. Thank you, one person. All the rest of the people can't spell. All right. So if you have a log base b of b, then the answer is whatever that exponent is. Same thing. So 1 and 3, as I said in the last class, property 1 and property 3 are what? I don't believe y'all are that dumb. So we're just going to sit here until somebody answers it.
Hey.
Thank you. One person from Easley again. I appreciate it, Pendleton. I appreciate all y'all's help and interaction. Do y'all do this to all your classes, Pendleton? I can expect that from Oconee, because Oconee, she's sitting there by herself, so I can expect that. But why are y'all so quiet, Pendleton?
We don't have an answer.
You don't have an answer. Thank you, JC. I appreciate that. So is it introversion, or is it just, something happened when y'all were children, or what? What is it? Or is it y'all just being anal? Which one is it? I'm prone to think it's 3. I think it's you just being anal. And you actually think it bothers me. I could care less. But anyway, you got log base b of anything is equal to the what? It's equal to the exponent. And what is the log of 1? Always.
0.
Thank you. The log base star of 1. Please do not type the log of 1 into your calculator. I don't care what base it is. Okay? Now, again, I wanted to bring this up because a lot of times people forget this one exponential. 2 to the x is equal to 2 to the 4. What's the answer to that equation?
4.
X is equal to 4. When the bases are the same, and I'm just bringing this up because a lot of people forget this. When the bases are the same, the exponents are what? Equal.
Same.
So x is equal to what? You're going to need that later on. All right, any questions on those basic properties? I'm just going over the basic properties because 1, maybe somebody wasn't here last week, and 2, if you don't know these basic properties, don't even show up for the test. Because it's kind of like, how the shortcuts were? The 5 shortcuts, and if you didn't know them, you pretty much sucked. Okay? If you don't learn this definition of a logarithm and these basic properties that we're going over right now, just don't show up for the test because you're going to fail it. Okay? So there is 6, 7, and 8 right there. Now, if you wasn't here, write them down. What's the first one called? What's the first one called? Pendleton, what's the first one called?
Product rule.
Thank you. I know that was probably JC. Product rule. Easley, what's the second one called?
Quotient.
Thank you. And I'm going to pick on Oconee Hall since there's only one person. Does it spell with an E or an A? Don't look right. I hate when I spell something and it doesn't look right. Somebody check that. Quotient. Is it E-N-T or A-N-T? Oconee, what's the number 8 called? But you wasn't here last week, so you might not know but it starts with a P. Do you have any idea, Oconee?
No, I'm sorry.
I'm sorry, what?
I don't know.
Okay. Who knows from Easley and Pendleton?
Power rules.
Power rule. Thank you. Now, the reason I want you to know the names is so you won't sound ignorant. And the other reason I want you to know it is because they apply or they correspond or they coincide with the what rules that we went over the other day. The exponential rules. A to the n times a to the m is equal to a to the n plus m and so on. A to the n divided by a to the m is equal to a to the n minus m. And a to the n raised to the m power is equal to a to the n times m. That's your basic rules of exponents. So there's two reasons. One, so you can see the correlation, and two, you don't say, oh, that's where you add those two logarithms together. You use the product rule. And both of them, you can go both directions, and you will see that that's important later on. When you're given these, you can write them in both directions. Except for one more rule. Basically, we've pretty much covered anything to do with logarithms, and that's the change base formula. I don't know where they have the change base formula in here, but it's the only one left, really. So if I wanted to rewrite these, I've got the same base. Again, you have to have the same base. All right? So this first one, I've got the same base. Take my handy dandy. That is the same. Oops. Take off the Y part. That's the same. The log base 5 is the same, so I can rewrite that. But before I can rewrite it, I have to do one thing. Somebody tell me that's had this before. Somebody tell me what I got to do. Let me ask you this, Pendleton. Show me how many people remember logarithms very well. Okay? How about easily? How many of you remember logarithms very well? Okay? Oconee, all I see is a wall because you don't make much noise up there, so the camera doesn't turn around. So knock on the table for me, Oconee. Keep doing it until the camera turns around.
I'll just talk. Maybe it'll it's not turning.
There you go. Do you remember a lot of your logarithms?
Vaguely from a previous class.
Okay. As a general, I'll start with Oconee. As a general, there's only one person there because you can speak for yourself. How many semesters or months or years has it been since you had logarithms? Roundabout.
I feel like I did it in high school and then also like a semester ago.
102 or another college algebra course or what?
Yeah, but it was very vague. Like it wasn't super
introductory.
Yeah.
Okay, how about easily? Just a general consensus. I only see 4 people, so I don't know if the 5 or 6 is usually there. Okay, you can speak.
I did speak.
Okay, now I see 5. Okay, now there's 5. Okay. How many, just give me a roundabout. How many years has it been? Months? What? Semesters since you've seen logarithms?
About a year.
About a year?
A year.
Guys, y'all can talk too.
I don't remember.
Okay, y'all suck. All right, Pendleton, how about y'all?
I've never done it.
You never seen logarithms?
It's only been a year.
About a year? JC?
Never done it.
Never done it. How about the rest of y'all?
Did it last year.
About a year.
Do you remember them?
Not really, no.
Okay. How about the left side of the room over there, or the right side of your Pendleton?
It's been like since 10th grade.
10th grade? Anybody else want to speak up? Okay. As far as calculus, these are, and especially business calculus, these are like the shortcuts of the graph. Okay? You know how in algebra, if you didn't learn the shortcuts, you pretty much failed the test because everybody was finishing the test and you were still using the reverse FOIL method? Okay? That's what this is. So it's on a scale from 1 to 10 on necessity, it's about an 8. About 8 or a 9. So make sure you learn how to use them. First of all, you're going to use the power rule. What are you going to do with the power rule? Tell me what you're going to do. Somebody that might remember. Use the power rule to do what? Anybody have an idea? Look at your power rule. What does your power rule say? That if you have a power, you can pull it out front, or if you have something out front, you can pull it into the what? Exponential slot. So what can I do with this 3 right here? I can make it a exponent. And now I have log base x, 5 of x, plus log base 5 of y to the 3rd power. The reason I say log is the same concept as OIL. I know somebody that invented the word will say that I'm pronouncing it wrong, so I just don't fool with it. So I pronounce log just like dog. I pronounce it dog. Okay? Unless I'm talking about Georgia. And I pronounce it WG, sorry, W. I got to say W, right? Because if you don't say W right, you're a racist Southerner. Okay, so I've got plus right here. So what am I going to use now? Okay, narrowed it down. We already used the power rule. So that narrows it down to what? The quotient rule or the product rule? Which one is it? The product rule. So I'm going to rewrite this as log base 5 of y to the 3rd over what? I'm sorry, I just decided to use the quotient rule for some odd reason. I suck. That's going to be, well, I'll get to y'all in a few minutes, as soon as my pen decides to work. Damn Russians. There we go. All right, who's got a question on that one? If I give you 30 questions on the test, 10 of them are going to be like these 2 right here. So you better learn them. And they're not going to be as easy as these 2. They're going to be a cluster. Okay? Nested cluster. Remember, 2 or 3 properties in one problem. Okay? Do the second one. If you can't do it, just consider yourself a failure and a disappointment in life. Right, Pendleton?
Yes.
I don't know what I'd do without Miss Vickery and JC. I don't know what I'd do. Probably lose a lot of sleep at night worrying about Pendleton. When I do my class evaluations at the end of the semester, put Pendleton campus and just a blank for no interaction, just a blank, just leave it blank. And then I got other classes. Oh my gosh, I got 2 classes that, oh my gosh, talking about social awkward. I would much rather have Pendleton campus not talk than a socially awkward person in the classroom. Have y'all ever had that in y'all's classroom? I got 2. I got not one. I got 2 classes with socially awkward people in it, and the class will not talk because that person, if anybody says anything, they just go crazy and just start talking out loud and stuff, and I'm just like, oh my God. They like laugh at stuff that's not funny, and they like laugh 15 minutes after everybody else has quit laughing. I mean, it's just, y'all know what I'm talking about? Okay, laughing is good, I guess. I wish I could record it, but I can't record it because I can't make fun of people. But, oh my gosh, it's awful. If you've ever had a socially awkward person in a classroom, you'll never forget it. Okay, what we're going to use first? Nope. You're wrong. Get out of here. You're a failure. What?
Power rule?
What did she say? Power rule.
Power
Yeah.
rule.
You are a winner. Anderson campus sucks, all right? But you are a winner. Now, what do you use after the power rule? After the power rule, what do you use? The quotient rule. Always address the powers first. Please excuse my dear Aunt Sally. The exponents you want to apply first. Okay? So now we've got log base A of what? 1/2 minus, well, we're not going to be able to use it. No, we're not. Log base 10 of B to the what? Now we cannot use the quotient rule. Why not?
Where did you get 10?
Wait. What did I say? What did I say in the previous slides? If nothing's there, it's assumed to be what? Assumed to be, yeah.
So like the A right there? Oh, okay.
Now, take my handy dandy highlighter. Now, I don't know if they want to use the change base formula. I don't think they do because I don't think we've seen it yet. So I'm just going to take my handy dandy highlighter and I'm going to highlight this one, that color, and I'm going to highlight this one, that color. Do we have the same bases? No, we do not. So here we had the same bases. Now what I mean by the same bases is log and the base, okay? Log and the base. That means the same base. So here, basically, that's as far as we can go unless they want to use the, and that's going to be a cluster because that's going to be log of 1/2 over the log of A, which really doesn't simplify anything. So I don't understand this because unless they're using something else, I really think this is supposed to be an A. I think they messed up. So let's say that this is an A. Then you could say log, we're going to change it because I think that's what they want. What will that be? Log base A of what? 1/2 over what? 5. And what's 1/2 over 5? Well, divide a fraction by a fraction, you multiply by the what? So that's going to be log base A of what? 1/10. I believe that's what they wanted to do because looking at the directions, there is no way without the change base formula that you can make this into a single logarithm with a different what? Base. So I think this is supposed to be log base A. So we'll see when we look at the answer and see what they did.
So you divided the 1/2 by 5?
Yes, because that's the change base what? I mean, not the change base. That's the quotient rule. Whenever you subtract logarithms, what do you do to the exponents? Divide. And when you divide 1/2 by 5, you're really dividing 1/2 by 5 over 1, which means that you multiply by the what?
Reciprocal.
As in trade, yes. My son found, I put found in quotation marks, I bought a Gear 2 watch a while back, and I lost it. My son found it. Guess where he found it?
Huh.
Anybody want to take a guess? In his room. So for 6 or 8 months, I haven't, well, I really didn't really get into it because I really don't understand the whole concept of a watch because it's so small, you can't really see anything. So I don't understand it. Somebody might want to help me out with the concept of it. I don't.
An Apple Watch or a Fitbit?
No, I like Fitbits. Fitbits actually have a reason, but I really don't understand. Now, Fitbit was on this, which they do have a little, but don't work very well, a little heart rate thing, and I'd rather just have a Fitbit because I've got Fitbits. But I just don't understand the concept of this. So somebody needs to tell me why you actually have one of these. Tell me the application. Besides a watch. Okay.
Never miss a call. Right?
You never miss a call. Well, you have your daggum phone on your side. How you?
I know.
You can't talk. I mean, you can talk on the thing, but I don't understand the concept of these things. I really don't. So.
They look cool and they sell.
Oh, now we get to it. There, that's it. I've got an acquaintance. I'm not going to call her a friend because she gets on my nerves, but that's all she worries about. What you just said. It's all she worries about. Okay, appearance. She'll go into debt trying to look the part. Let's see if we did this right. Look there. We got that right. I want to see what this one was because I think they made a typo here. Now they're going to put it over it. They can't do that because that's a log base 10. They were supposed to put an A right there. No, or I think they're changing this. Hold on.
Probably, yeah.
No, they're...
Okay.
We did this, didn't we? We did this, okay. Yeah. See there? You can't do that. No, they're using the change base formula, I believe. No? No. See, look what happened. What happens to the A right here? They made the A. They can't do that. Okay, I know what it's supposed to be now. Change it. This right here is supposed to be, this is what, right there, it's supposed to be 1/2 log of A minus 5 log of B. Everybody see that?
Yep.
What when they typed this PowerPoint up, this was in what? The subscript, and it's not supposed to be. It's supposed to be right here. So now you got log base 10, log base 10. Now you have the same base, and that's why this is log base 10. So make that change, okay? That's a typo. So the actual problem should read 1/2 log base 10 of big A minus, not capital A, big A, like not a base, not a subscript, minus 5 log base 10 of B. That's an error. All right, try that. This is a nested problem. You got 2 or 3 properties in this problem. The first thing I would do is address the 2. I would do that first, then I would address the 7x. So what are you going to do with that 2?
Get an exponent.
Make it an exponent. So you're going to swing it up top. Now you also need to read the directions. It says it's a what? A single. Because somebody might be inclined to make this natural log of 7 plus the natural log of x. That's not making a single logarithm. That's making 3 logarithms out of 2. So you're going the other way. That's not correct. You want to take this 2 and you want to pull it up here, and that's going to give us natural log of 7x minus natural log of z to the what? 4th. Now, if you wanted to turn this into log, you could. Log base e of 7x minus log base e of z to the fourth. Now, a lot of you say, well, why would you do that? There's going to be instances, okay? There's going to be instances to where if you turn things into the natural log or log base c, especially if I give you, watch, natural log of e to the fourth power, you may say, I have no idea how to do that, but it's real easy. The answer is 4. How do you know that, Hubert? Because what is the natural log? Log base what? E of e to the fourth. What happens to the e's? They basically cancel out, and what's the answer? 4. So this is something that I use, and I tell my students to use. If you've got natural log of something, sometimes it might behoove you to change it to log base e, especially if you're taking the natural log of e to the base power, okay, or whatever. So, you know, you don't have to do this, but that's just something for your information. So, do we have the same base?
Hey, Hubert.
Yes.
Why did you put, when you moved the 2, why did you move it and change it to a 4?
It's the drugs. It's the drugs and the bourbon. You know, you take drugs and bourbon together and it just doesn't work right. It's about like drugs and tequila. It just don't work right, okay? I'm sorry. I don't know where the 4 came from. Now, the 4 over there, I just made this up. I just made this up because sometimes you can use the natural log base e. You can use that to your advantage, especially when you get into Calc 1 and Calc 2. So, what can I do with this guy right here? What can I do now? That highlighted, that green subtraction symbol means that I can use a property. Which one? Quotient rule. So that's going to be 7x over what? Z to the fourth. Or you can write it log base e, log base e of 7x over z to the fourth. Okay, now I'm opening up for questions for any of those people that said they didn't have a clue about logarithms. While I match enter and make sure that we know what we're doing. There we go. Z, why do I keep writing 4? Hey, gone. Sorry.
We don't have to change 7x at all?
No. But what people do, this is what people do and they get it wrong. Natural log of 7 plus the natural log of x minus natural log of z to the second. Is there anything wrong with that? Is it mathematically correct? Yes. But what does the direction say? I'll say that for y'all if y'all can't read it. Single. Okay? Appreciate the non-interaction. Now, what if it said rewrite each of the following expressions as logarithms, plural? Then you could do this. Logarithms, plural. Logarithms. Nah, that's wrong. That's not grammatically correct. Hold on a second. I know I have somebody in here that invented English, so there. Thank you. Pretty good for a redneck, right? All right. That's the third question. That's 3 questions right there that are good test questions. So let's go to the next section, because basically, unless the change base formula comes up, this is all we're going to be doing through the whole I don't know how many sections are in chapter 5. How many sections are in chapter 5? 7. I guarantee you 6 of those have to do with what we're doing. The rest of them is going to be equations. So let's see what the next section is, and I'll tell you if it's important or not. Should have the change-based formula in it. Okay, they're going into the equations. That's good. I'm glad. Because equations, I would pretty much say, let me go to the whiteboard, that when you're talking about the logarithm test or a logarithm test, you basically got 2 types of questions. You've got the rewrite, and then you've got the solve. Okay? The rewrites are the ones we just did. All right? And we're going to do more of them. Okay, so if I give you log base 10 of x to the 7th multiplied by y to the 3rd, then I could go, since I've got a single logarithm, I'm going to write it as log 7 log of x plus 3 log of what? Y. I just rewrote it. Okay? Rewrite are expressions. This is algebra. What's expressions? Expressions are terms without a what? Without a what?
Solution.
Okay, I'll do this again. Without a what? Without an equal sign. That's why it's not called an equation, because it don't have an equal sign. And the only thing you can do with an expression starts with an S. It's what? Simplify. The only thing you can do with an expression is simplify. I guarantee you there's somebody out there that didn't know that. Okay? Solve. When we solve, we don't rewrite, we solve. And that has to do with what? An equal sign. So therefore, it's not an expression, it's a what? Equation. And what do you do with an equation? Starts with an S.
Oh.
You solve it. So in this, we'll have log of 10 plus log of x is equal to 14 or something like that. Now, the good news is they're not very difficult. The bad news is this right here builds on what? That. So if you suck at the properties, you're going to suck at rewriting. If you suck at rewriting, you're going to suck at what? Solving.
Oh.
So you got to know those properties. You're talking about 50-50. Yeah, you might have a 5.1 exponential graph. Y is equal to x to, or 2 to the x power. Yeah, you might have one of those questions. And you might have a graph log base 10 of x to the 5th power. You might have that question. The other 28 questions or the other 18 questions are going to be these two right here. Either rewrite or solve. And you think I drilled completing the square? We're going to drill this the same way. I'm going to give you problem after problem after problem. We're going to spend the next 2 or 3 weeks, whatever is left in the semester, going over these 2 type problems. So you may not talk in here, but you're going to learn something unless you're non-sentient. And there are plenty of non-sentient people. Ask a question and they look at you like, huh, what, huh? So let's look at okay. And you can take a picture of this or you can write it in your own terms, but it's pretty much Accurate. Solve an exponential equation by writing it in logarithmic form. Convert logarithms using the change-based formula. We're going to do that. Solve an exponential equation by using properties of logarithms. That's what I just said. Solve logarithmic equations and solve exponential and logarithmic inequalities. I'm not too keen on that last one because you don't use them very much. Listen, if you go into my Math 130 and you know logarithms as far as the first 4 of those, I'll be very, very happy as a teacher. I'm not really worried about the inequalities because it's just like algebraic inequalities. If you can do an inequality with algebra, an equality with algebra, an equation with algebra, the inequality is no big deal. All right, the same thing. I'm not going to go there. It says solve the equation 3,000 is equal to 150, 10 to 4t. Write that down if you haven't got it yet. Now, first of all, you can actually divide both by 150. Okay? I'm going to do that first. Now, I don't know how. Is there different ways to solve equations? Yes, there's different ways. I have no idea what they're wanting to do here, but I have a feeling that what they're going to do is they're going to take 300 and divide it by 150. Do not reach for a calculator. You do not need a calculator. Please, 10 to the 4t. I'm going to take that out. And how many times will 15? Okay, now this is real rough stuff here. 20?
Yep.
Now, what do we have? What is that? I'll take any answer, and then I'll make fun of you if you get it wrong. That's a joke. I'm not going to make fun of you. Sense of humor, it's always good to have one of those. Some of y'all need a lot of help with that. 20 is equal to what? 10 to the what? 4t. What is that? I didn't hear the words you just said. Exponential. It's an exponential what? Thank you. You paid attention. Mr. Quiet here, that I couldn't hardly hear him, and he's sitting right beside me, said exponential equation. Write that down. An exponential equation. When you have an exponential equation, you're going to have to use logarithms. Why? Well, unless you can make the 20 into a base of 10, which I think you can. Let's see. No, because 20 to the 1/2 power is not 10. So you can't say 10 to the 2nd power. You can't do that. So you're going to have to use logarithms. Now, let's go back to the definition of a logarithm. What is the definition of a logarithm? Y is equal to the log base A of what? X. And what's that equal to? X is equal to A to the what power? Y power. Somebody check, make sure I didn't mess it up. And I do use A instead of B. But isn't that the definition of a logarithm? Yes or no?
Yep.
Okay, what do I have on the left side? On the left side of the definition of a logarithm, what do I have? A logarithmic what? Starts with an E. Q. Equation. What do I have on the right side?
Equation.
What'd you say a while ago?
Exponential.
An exponential equation. An exponential equation. I got this as an exponent. I bet I could rewrite this like this. Rewrite it. So I'm going to go over here and I'm going to put, okay, that's 20 is equal to A is 10 to the 4t power. So I'm going to put that there, put that there. So tell me what the logarithm says.
4t is equal to log to the 10th base
Log base 10 of what?
20.
Okay, finish it. Now you have nothing but an algebra problem. What? Huh? Yeah. Take your calculator out because none of y'all are Rain Man. Okay? So you're not going to be able to tell what the log of 20 is in your head. Because if you were Rain Man, you wouldn't be at Tri-County Technical College. You would be at Las Vegas, dang old counting what? Cards and money. Y'all never seen Rain Man, have you?
You know.
Yeah. It's not Walt Disney and it's not a cartoon, so y'all haven't seen it.
I should see that.
Okay, I want to show you a trick learned in the war, and this is very important in calculus. All right, very important. When you dang old see this right here, when you're solving equations, always remember that this is a number. What do I mean by this is a number? A lot of people look at log of 20 and they go, oh my gosh, how are we going to solve for that? What are we going to do? Log of 20 is nothing but a what? It's a number. It's a decimal, right? So how would you solve? Let's go back to pre-algebra. 4t is equal to 2.1. How would you solve that? Divide both sides by what? 4. So all you're going to do down here is divide both sides by what? So t is equal to, somebody take the log of 20 in your calculator and tell me what you get.
1.30.
1.3.
I'm sorry, what?
1.3.
1.3 over 4, and somebody tell me what that is. Point what?
325.
0.325. Did everybody get 0.325-ish?
Yep.
Okay, now I want everybody to take your highlighters out or take your colored pens or your crayons or whatever, and I want you to highlight this log of 20. And I want you to put somewhere on it, this is a number, it's a decimal. It's just like back in pre-algebra, it's just like a number. So don't be intimidated when you see it in an equation and you go, I don't know how to solve that. I don't know what to do. It's basically a decimal. So many students get hung up in calculus when you're dealing with logarithms and derivatives. All you got to do is pull the logarithm out because it's a what? It's a number. So if I want you to take the antiderivative of 2x times the log of 20, the log of 20, if I do this right here, 2x log of 20 dx. Okay? Now that looks complicated, but it's not, because this comes out because it's a what? What's log of 20? What is it? It's a number. So you just pull it out. You don't take the derivative of the log. And so many students will see this on a test and they'll go, I'm going to the next one. And all you have to do is, that's going to be 2x squared over 2. The 2's cancel. That leaves x squared plus c. And your answer, log of 20. What was log of 20? 1.3. So this is 0.3 x squared plus c. Real simple. But you look at the log base 20 and you go, let's see, what's the derivative of log? What's the antiderivative of log? You don't take the antiderivative of log of the number. The log of a number, that's a number. You pull it out. So what I'm trying to tell you is always remember that when you take the log of a number, that is a decimal. It's a number. It's a constant. You can pull it out. It's not a big deal. And I said that 4 or 5 times for a reason. For those that are sentient and those that are actually paying attention, you'll see it later. Let's see what they did. It's a miracle. 0.325-ish. Is that a test question? Hell to the yeah. Will you see 5 or 6 of those on the test? Yes. Okay, this is how you solve it, and I really don't care about this, but you can solve it. Okay, what do we do when we want to find the intersection point? We set them equal to what? Equal to each other. So 3,000 is equal to 150, blah, blah, blah. You just take the 3,000 over to the other side and you intersect. That is a test question, but you're supposed to do it where? On a calculator. We're not going to do that by hand. You don't, well, you can. But we just did, divide by 150, and yeah, we just did that. Okay. Next. All right. Dang old continuous interest. S is equal, prove in time it takes an investment to double its value is T is equal to natural log of 2. So you're going to plug that natural log of 2 over R in for what? T. That's what you're going to do. Well, they are, okay, you're going to plug it in at the end. So we'll go ahead and do that. They did it backwards, but that's fine. You can do that. Take the definition of a logarithm and put that in the definition of a logarithm. I hate writing in red, so I'm going to write in black. I'm sorry. I shouldn't say either one of those colors, should I? Somebody think up a word for red and a word for black, please. All right. S is equal to P, E to the RT. Okay, let's see. Y is equal to log base A of X yields X is equal to A to the what? Y. Okay. X is equal A. Shoot. This is so irritating. X is equal to A to the Y. And use the definition of a logarithm, and that's what they're doing. I think that's what they did. Yeah. Yeah. I'm a little bit confused on the 2p though. Where did they get 2p? You're supposed to divide by p. Okay, prove that in time it takes from S is equal to P. Okay, something is wrong with their algebra. You can't just start with 2P when it's not in the directions. Does everybody see what I'm talking about?
Yes, sir.
That P right here, that's not correct. I don't know where that P came from. Because actually you're supposed to take P and divide both sides by P is what you're supposed to do. Because the P is in the way, this is what you're supposed to do. S 2P. Okay, am I missing something somewhere? Prove that the time it takes for an investment to double its value. Okay, that's where they're getting the 2P. I'm sorry, I didn't see that. Double its value. Okay, so 2P, that's supposed to be 2A, 2S. I don't know why they have that, but or you could change it to P. The principle, that's what they're saying. They're saying that these two is equal, so whatever. I don't agree with the way they're doing it, but the point is you're going to use the definition of a logarithm. I hate when they do this. 2p is equal to p e r to the t. What is the principle? Any of you business people out there know what the principle is? What is the principle? And you spell it like you do the principal at school. Principle. Okay? What is the principle when it comes to business? It's what you put into the what? Savings account. Okay? It's the amount that you're putting in. Okay? So what they're saying on double its value, so that would be 2p, and they're changing that s into 2p. Okay? I don't agree with that, but it's their book, so they can do what they want. I didn't write a book, so divide by p, and you get 2 is equal to e to the rt, and now you can use the definition of a logarithm. 2 is equal to e to the rt. So, what is y?
RT.
RT. And log base what? Base what? E. I remember log base E is something. Is what? 2. So RT is equal to natural log of E is natural log of 2. Natural log of 2 is basically a number, but they're wanting to see if this is equal. If I solve for t, what do I get? Oh, is it equal? Yes. T is equal to the natural log of 2 over r. And what they're wanting you to see is basically this transition right here. They're wanting you to see from that to this.
Well, wait, if we do our homework, like, does it expect us to know to change that to like a 2p, how it changed the s? Because I wouldn't know to do that.
I wouldn't worry too much about that problem because you're not talking about a lot of questions on the test, and you're probably talking about very few on the homework. But yes, they're changing s into 2p because of this right here. Double its value for some reason. There we go. Double its value. The s turns into 2p.
Okay.
Suppose $25,000 is invested in an account earning 6% annual interest, compounded continuously. How long will it take for the amount to grow to $5,000? The interest is 6%, so that's going to be R is 0.06. T is what you're trying to find. Natural log of 2, so they're basically going to have to turn it back into, there's your T, so 11 point, okay, that's what they're trying to find, 11. So it's going to take 12 years. No, this is B, I didn't know, I thought this was a different question, I'm sorry. So B to this question is, it will take you 11 years for 2,500 to grow to what? 5,000. There's the change base formula. All right, this completes all of your logarithmic properties, so write it down. There it is. I'll tell you what, just write it down like this right here, because most of your problems will be like this down here. Okay? And you don't have to remember it, because most of the time you're going to start, when you start using it like log base 5 of 7, you're going to say, okay, that's log of 7 over the log of what? I mean, log of 7 over the log of 5. Log of 7 over the log of 5. And now you can do it in your calculator. Because what's the base here if nothing's there? 10. And that's what it's saying right here. See, there's no base here. So that's log base 10. And this is log base what? LOGE. LOG base E of X over LOG base E of A. So if you have, here's an example right here. If you have the LOG base 5 of 7, you cannot do that in a calculator. All right? So what do you have to do? You have to change it. And it's always going to be this guy on top. That guy right there is always going to be on the top. And then the base will be on the bottom, on the denominator. So somebody take your handy dandy calculator and say parentheses log of 7, close parentheses, divided by parentheses log of 5, close parentheses, and tell me what the answer is. What do you come up with?
1.2.
I'm sorry. What?
1.2.
1.2. Did everybody else get that?
Yeah.
Okay, you need to write that down because that will be a test question. It's going to be just as simple as that. I'll only give you one, but I'm trying to tell you what the easy questions will be. A couple of graphing, and then maybe one like this. The rest is going to be all formulas and change base formulas. Now, we haven't got to the hard part yet. We're getting there. Okay, here's another example. Somebody take the log of 24 and divide it by the log of 8. You can actually do these in your head and punch it in the calculator. There's no work. So somebody take the log of 124 and divide by the log of 8. What do you get? Should be 2.3-ish. And I want you to take the natural log of 124 over the natural log of 8. And you'll see that it gives you the same answer. Did you get it? 2.3-ish?
Yes, sir.
Question so far? So, what you need to do right now is write down all of the hold on a second. Let's see what time it is before people start going into emotions. Okay, we'll do the. I want you to go to Google. I got 2 minutes for those of you that's going to what do you call it? Spontaneously combust. Oh, in trig class, they're going to knock the door down. It's 11. They get here about 45 minutes early. Okay. Go to Google. Now watch this. This is some hard work, so you may have to take notes. Okay? Log space properties. Okay, I've hit one button to get Google, so that's the second button. And images, that's the third button. So right now we're at 3 buttons. Okay, so a lot of work here. And you can click on whichever one you want and print it out however you want. You know, you got all kinds here. No, don't do just do logarithmic properties. I like this one right here, I think. This is the best one, looks like. Yeah. Okay. I would print that out and keep it. Okay, until you learn them. So that's 4, and then you have to hit print. You're going to have to, save image and maybe print. So maybe 5 buttons. And then you have to send it to the printer. And then you have to get up and go over there and take it out of the printer. So, like I said, it's a lot of work, but hopefully 1 or 2 of you will be able to do that, okay? All right, now y'all are responsible for 5.1, 5.2, and 5.3. We'll continue when you come back. Everything that we are going over right now is going to be on that last test. That will be the last day of class through the last day of exams. So 5.1, 5.2, and 5.3. Y'all have a great Thanksgiving. And keep it between the ditches.